Hey, there he is.
Hey, sounds good. Yeah, I just happened to check my email and saw the meeting starting a minute ago. So I'm ready.
Rock and roll, man. Excellent. Excellent. So, shoot, where are we at? Paul, you wanna kind of kick us off here?
Yeah, sure. Can you guys hear me all right?
Yeah, you sound good here.
Okay, great. Messing with my audio settings. Yes. So not too much progress has been made over the last 2 weeks. I think everything I don't know about you guys, but everything my world got turned upside down with the Solana transition. But I think that that's pretty much calmed down now, and I'm ready to kind of refocus on this project.
And it wasn't too crazy. I mean, I think the transition actually went rather smoothly.
It went really well. Yeah.
Yeah, I was quite impressed. Obviously there was a lot of work that went into that to make it go so smooth. But I'm really happy with the way that went over. So
Yeah, absolutely. So the state of the Beacon project is the schematics are pretty much done. The bomb is pretty much done. If you guys want to check out the schematics and the bomb or the whole project, all the project files are they are on GitLab. So kind of to remind everyone, so we're in KiCad here. This is the 3D viewer. So we have the two sides. I've modeled out the keyboard, the screen, and started placing some of the components. There's still a good amount of work here to place all the components and then route them. So that's kind of the state there. I wanted to show off this. This is super cool. Every time there is a build,
yeah.
Are you guys familiar with this?
Oh, this is so awesome. Yes.
Yeah. So this is one of the plugins you can enable with KaiBot, which is a automated script utility essentially that builds a bunch of cool stuff. One of the outputs here is a interactive bomb tool. So you can see all the components as part of this PCB. You can also click on the individual ones. You can see, the name, what type of component it is, and where to place it. And so this is really good if you are doing hand assembly. This is freaking awesome. And it's also just really good just to get a nice overview of your bomb in general.
Because this highlights one at a time. Like if I'm doing hand assembly, I could go through and just
Or
you just
you could output the whole list to a pick and place machine. If you put the XY positions in CAD, the vectors, you got a pick and place machine ready to run.
Yep, 100%. And that's another one of the outputs we can enable here. Like Travis was saying here, you can go through the components one by one and you can see how it's highlighting. And so it can tell you where to place it. It's great. So that's kind of just one of the outputs. I wanted to show you the project file. So here we are at gitlab.com/enlightensystems/beacon. This is kind of where all the project files exist. I have a quick little README. And here is where the KiCad project files exist. So yeah, please check that out. Take a look at it, send pull requests, all that good stuff. So that's basically it. I think so. The next steps here are to do some routing, some placing and routing, and then we've kind of reached the next mini milestone here, where we'll probably be ready to send it to a PCB manufacturing house and get some assembled.
Excellent. And I guess some of the big questions that we had brought up in the past is, what are we using, at the core of this, for our microcontroller, how are we building this up? And can we kind of address those and, for the call here?
Yeah, 100%. So I have chosen the Raspberry Pi 2040 as the main microcontroller. This is a great microcontroller. It's dual core. It runs at, I think, 200 megahertz or so. The coolest part about it is you can choose any size flash you want. It actually works. It requires you to choose an external flash. So we can choose 4 megabytes of flash, 8 megabytes of flash. It's amazing. So like if we want to have a really nice UI with actual graphics and stuff like that, we can use all of that flash space. And the other really great thing about the Raspberry Pi Micro is that it's available in quantity everywhere for
Yeah.
$1. So I really like that. And now I think one of the other things that I think was brought up is being flexible and maybe having a what's the name of the port again? The pin compatible port, Travis.
You're talking about the Zhaos?
Yeah,
Okay.
yeah. So, I haven't, yeah, that's it. So this is kind of like a standard almost of what is it, like 10 pins or 16 pins, where you can kind of plug in different modules, right? Travis, maybe you could explain a little bit more about it. And
What this is, it's a standard pinout, but you can have different microcontrollers that work there. You can have a SAMD, you can have a Nordic 840, you can have the Raspberry Pi as well as a core that works in the same pinout.
Yeah, they're a minimum. They have a minimum GPIO footprint. Yeah. Zhaos are really nice. One thing I do like about the Zhaos a little bit better than the RP 2040 is the ability to have the Bluetooth and Wi-Fi support on board, especially with the NRF Zhao.
Yeah.
That gives a lot of power to it that is somewhat more difficult to implement on the RP 2040.
yeah, I agree. And I think the other cool thing that we could do here is I imagine there's like an ecosystem of sensor types too that kind of just can plug into.
Oh yeah. It
footprint.
works with the whole seed platform. So you got 5,000 sensors. You got whatever sensor offering they have will integrate pretty easily, given that you have enough GPIOs available. Because to maintain that standard footprint, they've reduced the number of GPIOs. So like you'll get a ton of more GPIOs with the RP 2040 than you will with the Zhao. Usually the Zhao offers you for a standard use like our application. If you were wanting to hook up, a bunch of other sensors, then you'd probably have some other interface like a data logger from Seed to the Zhao or something like that. But what the Zhao gets you is that foot in the door with all of Seed offerings.
So yeah, I like that a lot. So maybe let me kind of pitch this idea. What if we add a Zhao footprint, like just a pin header?
Yes.
That way, so we can,
fallback position too. It's a plan B. It's gonna. One of them's gonna be six. Say that 100%.
One of them's gonna work. Yeah, one of them's gonna work exactly. And I really like this idea of you have your beacon device, and then you can go to the ecosystem, the Seed Studio ecosystem, and go buy whatever sensor you're interested in, and literally plug it in the back. and through firmware magic,
What
we'll
you're
have to write
talking
a bunch of
about is pretty
integrations.
much the builder concept that Seed came up with, where they have a builder that interfaces with a data logger extension.
Mhm.
So the builder would be the Zhao, and he'd control all the data logger extensions. And once you have the data logger hooked up, it's like super IO.
Super
and
IO.
all the expandability goes right from there. So all the farmers that are building off the S2100 and starting to look at the S2110, one of those is the builder, one of those is, I can't remember which is which. They have that standard platform in place with the S2100. So, if they wanted to upgrade something communication wise, they could just slap this on the front end.
And I believe that gives us a little more flexibility as
Yeah, I
far
like it
as
either way.
yeah.
I'll say this much. Yeah. I have been tinkering around with the RP2040 and radio implementations, mainly the NRF. You have to use the Pico SDK to basically get anywhere. None of the Arduino libraries in Platform IO. You have to really pick and choose to get it to work. Similarly, on the Bluetooth connectivity, I can get it to work. It has to be done on the SDK. It's more of an intricate build, the way I would say it. Zhao's are drop-ins. I've worked with the ATMEG 328 and the RP20, or the all of the other Zhao's, and they're pretty easy. So yeah, that's just my input based on programming side.
So on the Zhaos, we would be pulling one of these guys in, using an E5.
You could use an E5. I mean, with a Zhao, I could use an RP or an RFM95. I can use anything because it has that core that works with all the LoRa built in. So it's the core.
So it depends what kind of stack we want to use.
Yeah, it's an easier stack. It's proven stack.
What's nice on those E5s is you have the native AT command, kind of built into them, and it is kind of easy just to talk to the radio rather than having to run a full stack with it. But I mean, we can go either direction here.
That is true. You could go either direction. I kind of think that it's a little bit more drop-in replacement with the Zhao. I fight with the RP 2040 as much as I'd love to have it work well. It just doesn't.
And another thing about these E5s.
So yeah,
this is the E5 Weo.
Yeah, just an opinion. I'm close to getting some SDK work done on it. I've done the Bluetooth implementation. The radio one is still giving me a little bit of a problem. I kind of took a pause on that for the last week or so. And I need to revisit it, and just want to know that I could get that build happening with the RP 2040.
One thing I would like to mention, about these E5s is if I want to reprogram those, I effectively overwrite the AT commands, and you cannot restore those.
True, that's a big pain in the ass. There's some hardcore hacking that you could do that's probably about as difficult as getting the RP 2040 to run to make it happen. But yeah, there is an option, but you do blow away all the protected memory that's pre-programmed by Seed, and in doing so, if you reprogram everything, it's not compatible with Seed.
Yeah, and unlike the WizBlocks, which do allow you to reflash the AT commands, Seed does not allow you to do that. So. Just wanted to throw that in.
So those are the trade-offs.
Yeah.
Okay, I like it. So, I think we should modify the schematic a little bit, add the Zhao footprint and make sure that it can kind of control the components that we want it to control.
Okay.
So there must be a I squared C in that footprint.
Yep. Yeah.
Nice. Okay, good. Because the keyboard talks I2C. Well, there is actually a second microcontroller that monitors all the numerous matrix, the keyboard matrix.
Yeah. Okay.
And like its sole purpose in life is to monitor that with GPIO, and then it speaks a I2C protocol to the main process. And that main processor can be the Raspberry Pi, or it could be a microcontroller sitting on the XAO bus, XAO footprint, whatever we call it.
And for the sake of the call, can we talk about what a matrix is and why that's necessary to be monitored?
Sure. Maybe I should share again.
Excellent.
All right, so let's look at the schematics here. Okay. So this is the top level schematic. Start with the Raspberry Pi. But we were just talking about the keyboard, so let's dive into, this is the sub sheet for the keyboard.
Nice.
Okay, so here is the keyboard. This is the BlackBerry keyboard connector. So basically the way this thing works is the keyboard is actually divided into rows and columns. And each row and column comes out of this connector. So, you know, we've got so many rows and so many columns. These are just basically GPIO pins. And they are connected to GPIO pins of this microcontroller. This is just a SM32, like low budget, pretty easy to find microcontroller. And so what this thing does is it has a very tight loop that basically just monitors the rows and columns of the keyboard just to looking if that key is pressed. And when it is pressed, it sends it cues a key press in a buffer that can then later be read over I2C. So it basically takes like this ton of GPIO, something like 20, and condenses it down to just 2 wires on an I2C bus that can be read.
And it allows you to push multiple keys at the same time, and so I can just mash a bunch of buttons and know exactly which buttons I pushed. Yeah.
Yeah.
So
Yeah.
for the most part, usually, that's kind of the trick of matrices
Now-
there.
Is that I2C bus? Is it does it have to be dedicated, or can other things be placed parallel on it? So would we have to have I2C 1 as the keyboard and I2C 2 as every other I2C we wanted to use, like for sensors?
No, it's not dedicated, and it can support multiple other devices on
Cool,
this bus.
cool.
So, for
Yeah,
example,
that's fine. Yeah. Yep.
Yeah, so for example, let's highlight the clock line of this, and then we will leave this sheet. So you can see this clock line in pink here. This is the same clock line that's brought out, and it's, let's see, it's being pulled up here. Where else is it being used? Nothing else is using it right now. So this is I2C1. But here's another example of an I2C device. Paste it. Here's one.
Yeah. Cool.
Yeah, so this other bus is being shared by the secure element, is being shared by the display and the battery sensor. And so that's all on I2C 0.
Yeah, that'll work perfect. Yep, good.
I like
So
it.
we can choose either I2C 1 or I2C 0 to come out to the XAO connector as well. While we're here, should we kind of like take a quick tour? So that was,
Yeah,
we
that'd be
kinda
great.
just did a little deep dive into the keyboard subsystem. Let's zoom back up here. So we're at the top level again. Let's dive into our radio display. What do you guys think? Should we dive into the radio power?
Let's start with the
display?
radio. Yeah.
Okay.
Well, yeah. I think that's a good way to start.
Okay. So here's
Yeah,
the
it's
radio.
like the
This is
heart.
This is, yeah. Now this looks like a lot of stuff. I basically lifted this from the reference design from Semtech. So if you go to Semtech's website and you look at the LR1110, they have
Yep.
a nice reference design. And so this is like, I changed nothing about this, almost nothing about this. So here's the main processor. This processor
And real
has,
quick, let me jump in and just say with Simtex LR1110, you may have seen these as a little black box. They have a tracker module that is effectively the same as the Digital Matter. They're small edge devices. They're Yabi Edge.
yep,
Is pretty close to the reference for the LR1110s.
yep, yep, exactly. And what kind of makes this radio processor unique is it has 3 RF front ends. So we have a front end for LoRa, and that could either be tuned to 915 megahertz, 868 megahertz, and a couple other frequencies. So that would be this big thing across here. So you know, like, can I
Yeah.
highlight with multiple things? Yeah, that's kind of what we're looking at here. It also has a 2.4 gigahertz front end that's used for Wi-Fi scanning. So the way this thing works is it determines your location using 2 methods. It can it can scan for local Wi-Fi access points, and then using a global database of access points and geolocations, it can say, okay, like, I know I'm, within 100 or 50 meters of this access point, and I know, like, my database is telling me that this access point is,
Yeah.
placed here on the globe, right?
And this uses LoRa Cloud.
That's
Is
right.
kind of the interface there. If anyone
Yeah,
is not familiar there.
that's right. So Semtech Semtech has something called LoRa Cloud, where they have this geolocation database, and so the you know it kind of alternates between scanning the 2.4 gigahertz, looking for access points, sending the list of access points to the cloud via LoRa, um, via the Helium network in this case, or um, whatever your LoRa
Yeah,
provider may be.
that could be actually like a fallback position. I don't see any GPS. I haven't gotten a signal the last time. That's 3 pings. Okay, let's try Wi-Fi.
Yeah,
I
Get a
believe that
location.
is commercial as well.
yeah,
Just
yeah. It
just
is
just
commercial. I think
throwing
that
that
you
out
do
there.
need to
Yeah,
you
no
need to
fun.
pay for it. If anyone has any connections to people at Semtech, we kind of
Yeah, you get the first 40,000 free, I believe, is how it works right now.
okay. That's how it works. Yeah.
Yeah,
I mean, the other thing too is we don't have to use their cloud. We could,
yeah, right.
we could crowdsource this data.
Yeah, we can roll our own on this, and
Roll
I
our own.
believe that they make this pretty available if you are so inclined. So
Yeah, which would be like
Yeah,
really interesting to go
that
about
could be
that.
kind of cool, actually, to do with this project. Yeah.
Yeah.
Couldn't we just use like Wiggle for free?
Uh, that's a good note there.
the other side is could we use our own data that we get from location assertions?
Yeah, that's a very interesting idea, and yeah, I would love to explore that.
Yeah, I like that.
That's ours. We own that. So
You heard it here first. Yeah.
yeah, squatters' rights on data.
Yeah. Okay, so
Interesting.
and then moving on to the other, so that was the 2.4 gigahertz. There's also a GPS RF front end here. So this is, I know less about how this works. The documentation makes mention of scanning like the GLONASS, and I'm not really sure what that means. So it's not a full GPS receiver. I don't think it actually like computes the triangulation for multiple satellites. So I don't really know like what data it gets here. Besides that, the documentation says it's low power, and it basically the front end looks like any standard GPS receiver. So we have actually two choices of antennas here. So there's a coax antenna. If you choose to plug in your own GPS antenna, you can plug in your own GPS antenna, or there is a PCB printed antenna.
And are these either or? I mean, do we have to switch between these, or can
It's
we?
either or. That's right, and it's controlled. That switch is controlled by this GPIO,
Gotcha.
and this is an RF switch. So this can either like basically connect one or the other antenna.
But it's all software to do that
It's all
switching.
software. That's right. This is a GP.
Right.
This is just a GPIO
Yeah.
that gets routed to the main processor. Yeah.
Very cool.
Yep. This is also optional. Like, we don't have to have this whole switch thing. Like, maybe if there's a compelling reason, we just go with the connector here instead of the printed antenna. I am actually not sure there's enough space on the PCB to add this printed antenna. So that's kind of yet to be determined. I'm not sure if there's a big reason.
Because on PCB antennas, you have to pretty much leave that part of the board just to the antenna. You can't really
Yeah.
use that for anything else.
Yeah, and you also kind of want to route other things away from it. Like,
Yeah.
you don't want to have a lot of you don't want to have a switching power supply next to it, because it's gonna
Right.
had a lot of interference and stuff. So it takes up a good amount of real estate. So maybe once we kind of get more into the routing side of things, we determine, hey, this whole RF switch in the PCB antenna is not worth it.
So on the PCB, I mean, is this something that we're talking about using like a UFL or just I mean, what type of
Yeah,
antenna
UFL.
breakout we want?
Yeah, and it would probably be. I don't have one right here.
Because we could use a tiny little dongle or a little, tail, on UFL to break out to whatever format you want.
Yeah, I think that's best. Yeah,
Yeah.
just
That's the way to
UFL. We're fixed. He mentioned the board is kind of dense, and we're gonna have to use a UFL.
Yeah.
I agree.
Cool.
Okay, so working our way back here, this is a low noise amplifier. Because GPS is the signal from GPS is so weak, you commonly need an amplifier. So that's what this is, and then this is goes into a differential bomb network, and change it into a differential instead of a single-ended pair. So that all just goes in there.
And we could turn this whole end off if we want, right? I mean, if we don't need this powered, we could just shut this down.
Oh yeah, that's right. So the only thing that's really going to be consuming any power here would be the amplifier for the GPS side of things, and that is controlled right here through this.
Nice.
Again,
Nice.
GPIO. In fact, like it just takes the GPIO driving power. Like it's so low power. It must be under probably 5 milliamps that this thing takes. So it can be driven directly from GPIO. So just turn off that GPIO, and you're turning off this whole part of this whole chain. What else is of note here? So there's a nice temperature compensated crystal that's providing the clock signal for the LR1110.
Mm-hmm.
That's about it.
Let's jump to power. Is that cool?
Sure.
Power is the thing that
Okay.
most people don't really jump to until the very last point, and that's always a bad move.
Yeah.
So
I find power very interesting, and this is very interesting in particular because it has a battery charging circuit, and a fuel gauge, because we want to be able to provide like a nice accurate in terms of percentage in the top right of the screen, how much battery you have. So to provide that fuel gauge, We have this chip, the RT9426. This is where the battery connector is.
Is this
comes in.
the TI chip? Or
I forget who makes this. How did I find this? I think I just did a search.
This sensing chip, I don't know. I've looked at them in the past.
yeah,
And really, just some creative voltage dividers on resistor ladders. You can accomplish the same type of sensing.
well, you could try to. I don't know.
Okay.
It gets pretty tricky here.
Yeah, just looking at from an electrical network standpoint, I'm like, I see a little bit benefit, but just note that if you don't want to use this or don't see a need, it's just drawing more power and parasitics. And if you could do it a simpler way, maybe that's something we need to consider.
I think that's why these chips kind of came into widespread use, because just using a voltage divider doesn't really get you as accurate as you want to be on these. I know there's a TI chip is why I asked that question there, but that's some pretty widespread use. But yeah, I got this. What, Rich Tech?
Yeah.
Okay.
Yeah, and
but noted. I understand your issue there.
If it comes down to a crunch and somebody has to move, he might be the first one to get evicted.
Yeah, that's fine.
But it is nice to know.
That's the way I say it.
I mean, to have an accurate fuel gauge.
And
Otherwise,
this is one of those I2C devices.
Yeah.
It can just be read anywhere. Okay, so that's the fuel gauge.
cool.
And then the battery charger is this one of these super simple. This is used pretty much everywhere.
And so this gives us constant current, constant voltage for like LiPo charging.
Okay, we'll get to that.
Okay.
This is just the charger. Like this component's sole purpose in life is to send power to the battery and make sure to cut it off. Well, it sends constant current to the battery while it's charging, and to make sure to cut it off when it reaches I think it's 4.2 volts, and also
on the low end.
Does it do the minimum? I don't think it does that part. So we don't have what's the other type of protection when you
so you don't completely kill your battery.
Discharge. We don't have under discharge, under voltage protection on this thing.
Okay.
Which
is critical. It's something that we have to pull into the design.
Yeah, you need a charge controller.
Yeah.
Yeah. Okay. So
we haven't even taught chemistry yet. I mean, which is gonna have a lot of bearing on what charge controller we use. I mean, if we're using just a standard LiPo, then I mean those are pretty cheap and easy. But
exactly, standard LiPo. That's what I had in mind.
But we don't necessarily. I mean, we could. I don't know. The display is really going to be having a big bearing on the battery, of course. But maybe we have a mode where you can run this. I don't know, on another power source. Just putting it out there.
12 volts.
It gets power over the 5-volt USB.
Or a supercapacitor. I mean,
supercapacitor would be super cool. Yeah.
Supercapacitor, I'm in with that.
Yeah. I mean, the display would kill us on that, of course, but
it's an e-ink display, unless it's changing what's on the display, it's not consuming power.
If it's e-ink, that's gonna be fun. That's just it's a little bit better.
We could do that. Or we could power off of the device that's programming it at the time,
Mm-hmm. Yeah, the USB.
Oh no! I mean using like a near field
From an expected life of 7 years with a battery versus a super cap, which is upwards of that. You don't have to change the battery. You don't have to recycle a battery. You don't have to.
Yep.
It's very. You could slap a seal that says this thing's nice and environmental friendly.
Yeah, I like that idea.
I kind of like where we're going here, folks. Yeah.
That's
So I super caps are fun, and know a couple people that have done some stuff in that space.
Yeah.
And technically, we could experiment with that, right, without it even changing anything, right? Because all this battery charger does is send power at a pre-programmed constant current, which is controlled by these two resistors here, and it cuts it off at a certain voltage, which would be
exactly what you need to feed a super cap.
Yeah.
All right.
Exactly.
I like
and
it.
that brings
I like
me
it.
to this. So there's two options here. There's two variants for this board.
Yep.
There is a buck boost, which will provide the main 3.3 voltage, or we could use just a linear regulator that will.
And both of these bleed power, basically. I mean, they're lossy, right?
Well, yes, and the linear regulator would be more lossy than the buck boost.
Yeah.
If you wanted to drain the super cap and just say, I want to power this thing down dead, you could do that in a second.
Yeah, with a linear
I'm just thinking. I'm sorry. Yeah, still kind of reeling about it.
Very nice, though. Very nice. Yeah.
So the reason why I went with two different possible variants here is that a linear regulator is a cheaper choice. It's less components. It's less expensive, but it wastes more in heat, right? So any voltage over your 3.3 voltage is just going to be wasted to heat. That's how linear regulators work.
That's what they do. Yeah.
That's what they do, exactly. But a buck boost works different, and this is actually a fairly expensive part from LT. But the cool thing about this is it can actually boost voltage that's under. So as the battery drains, its voltage goes down, and it goes down under 3.3 volts when it's really at the last 20% of its
So it can still maintain power to the device, once it dips under that.
Yeah, exactly.
When you say this is a fairly expensive LT component, what do you mean by fairly expensive? Just for so everyone on the call can understand.
This one component itself, I believe, is $5. Let's do a quick search. And that's why I kind of like it's a nice to have. It's a cool part to use, but
that's more expensive than our microcontroller.
By 5.
With that, point of reference, everybody.
With 5, you could buy 5 microcontrollers with this one part.
Yeah.
But so that's why it's an option.
But it's sourceable, which is nice, right?
But it's sourceable. Yeah. Let's see. Oh no.
Yeah.
Price went
up. There you go.
$750. Yeah. So this is a luxury item. If we are really concerned about using every last drop out of our battery, you're going to want to use this.
Yeah.
Otherwise, go with the cheaper option.
I mean, or if we're wanting to, have a battery source that may not make it up to full power, if we're using some type of energy harvesting, I mean, there's a number of reasons that you would want to use, a chip like this.
Yeah, exactly right. If you're using the super cap, super cap's going to drain all the way down to 0 volts, and all of that is usable energy, right? And so you're only going to be able to actually make use of that with a buck boost.
And so for $5, in certain cases, yes, it's definitely worth it. So very cool, man.
And you'll see on the schematics, there's actually 2 schematics. One says linear, the other one says buck boost.
Cool.
Let me show you what I mean by 2 variants.
And if someone wants to pull down these KiCad, schematics, they can just go to the GitLab
Yeah,
link.
100%.
And
So,
excellent.
so this is open source. It's open under the, I have the license here. It's the CERN open source hardware license, strongly reciprocal. So you are free to come to this repo, check it out, make changes. I hope that if you do decide to make changes, you'll contribute back
Yeah.
through a pull request or through our community here. But it's all here, so you can go check out the beacon directory, and these are all the KiCad source files.
And Paul, if someone isn't familiar with GitLab, but they know GitHub, you could
Same
use
thing.
the same setup that you have to pull down the GitLab.
Yeah.
It may seem a little funny, but we're all a little funny.
Exactly. But it's the same thing. It's all done through Git.
Yeah.
And if you don't have Git, you can actually just hit this little button and it will download it in a zip
Cool.
for you.
Thanks.
So that's where that exists. And then I was talking earlier about the automated, every time a new change is made, there's this automated script that builds a bunch of stuff. So you can click on this button and check out the build. And the build has a couple of artifacts. So we can go and look at the latest build outputs of this, which includes the bomb. So here's where you can find that interactive bomb that I just found, or I was just showing off earlier. So you can click here and go to, let's look at the linear, and it will bring us, here we are.
Here we go.
Now going back, if you want to look at the schematics, for example, that's found here in the schematics. And here's here's a PDF of the two different variants. So one is linear, one is BB, buck boost. So if we look at the linear variant, here we are, and and you'll see that this has automatically been depopulated. So this is the variant that doesn't have the buck boost populated. So you won't find this in the bomb. So that's kind of the way the variant.
That's pretty slick. Yeah, I like that.
What else is here? Nothing else here yet. Once we get into the finishing up the routing, we'll also get all of the Gerber files that are needed to actually send to a PCB manufacturer. Like that's like when you want to get a PCB made, your manufacturer asks, okay, send me the Gerber file. So that's the output.
Yeah. And Seed has been kind enough to offer up their fusion services to this project. Awesome. So, yeah.
Fantastic. Okay, so that is pretty much an overview of the power section. Does anyone have questions on this power side of things?
Nice work. I gotta say, I like it, man.
Thank you. One thing I forgot to mention is this little odd-looking thing. What this does is this can be powered off of the battery or the 5 volts from the USB. And what this thing basically does is it takes, it sends whatever has the higher voltage. So if you have the voltage, if you have the USB plugged in, that's going to be 5 volts. That's going to be higher than your battery, which is at the highest going to be 4.2 volts. And so that's going to basically come through here. But it basically it takes
it's a switch.
It's essentially a switch that allows power to go through, so you can power it off of either USB or the battery.
And backfeed things. So
you could actually do that with diodes. You could do that. You could make that transistor with like 3 or 4 let's see, 4 diodes.
Yeah.
Okay.
And by using a P MOSFET here, it's less lossy, right? Because
exactly.
Yeah.
It's less circular transient currents, but the diodes will get it done if you need to go plain and simple. It's effectively the same, not ideal circuit.
Yeah, for sure. Okay, we might as well go through. So let's see, we did the keyboard, we did the power, we did the radio. Let's go look at the display.
Yeah.
The display is highlighted right now, and that's why it's in green. This is a e-ink display from. I'll send the link out later, but
Which I think is a great call on this to use the e-ink.
yeah, I think it's going to provide it's going to present some challenges because the updating an e-ink display is slower. This particular e-ink display allows you to update the screen partially. If you just want to change one icon in the corner of the screen, for example, you can do that, and that happens much faster. Instead of like like the whole kind of like, I'm sure everyone's seen an e-ink display refresh, like a Kindle as an example of something like that. So when that happens, when you turn the page in a Kindle, it flashes a couple times, and it's kind of like jarring actually. But
do I just have to send deltas to it in order to
send deltas? There's a whole protocol that's described in the documentation for this e-ink on how to do the full refresh versus just the partial refresh. It works on a simple array in memory where each bit is just pixel on or pixel off. So very simple to do. So
I like it.
we could actually provide graphics, and again using all the memory space provided by the Raspberry Pi. We can really go to town with like graphics and user interface. Much more than you would expect from your common kind of microcontroller display. So I think we can really get creative and be pretty exciting here.
Cool.
So that's the display. So no touchscreen, but we have, besides the keyboard, we have two nice big tactile buttons on the left and the right. And then we have kind of this little joystick thing in the middle. So this up, down, left, right, and I think it even does the diagonals in every direction as well.
And a click is so it's not a 5 position, huh?
No, I think it is a 5 position. All right.
Okay.
No, you're right. Let me double check. I think that's going to be in the keyboard section. Yeah, so it's the 5-way switch.
Okay.
So sorry, you're right. But I think it does have a center push as well. Maybe it's not a push. Maybe that's just when the keyboard or when the joystick is in the center. I think maybe that goes higher or lower.
Okay.
Okay, but I think that will provide more than enough kind of input to whatever user interface we can dream up for this thing.
And the e-ink will be fast enough to do menus for us here?
Yeah, definitely. And that's kind of like where we can really take advantage of the partial display. So like you can kind of imagine like a menu where you want to scroll down and then select.
You just have an arrow on the left of it, which gives you position. Or
exactly.
Okay.
And so to update, you only need to update that little sliver of the screen that provides the arrow, right?
I like it.
So I think that'll work great. I think also like in kind of like if you're using this thing as a messenger, as a text, that's easy enough too, because you can write a line of code, and then maybe the line of code just shows up on the next kind of row. And then once you get to the bottom of the row, then you do the full refresh, right? But like, unless you're having a very verbose conversation with someone, you're kind of avoiding that full jarring e-ink display refresh, and you're just seeing.
Or do we have RGB LED, or something that we can use for like a heads up? Hey, you have a notification.
Ooh, that's actually a great idea. I do not have. We should write this down as a great idea.
If we tie that in, that way we don't have to do. We don't have to keep polling or looking for a screen update, and we can just have an alert there.
Yeah, like maybe we can have like a little RGB LED right here.
Just a little indicator. Yep, that would be perfect.
Yeah.
Then you're not having to refresh your e-screen every time because somebody's sitting there flipping out because they're waiting for a message.
I like it a lot. Okay.
Refresh.
And a rumble module, right? Okay, cool.
Okay, so the e-ink display comes in through this connector. I think it's really just it's kind of like a spy protocol, I believe.
Okay.
The the
Which is
documentation
good. It's fast. I mean, yeah.
yeah, and it just yeah. The
Yeah, I see
document
the
this
chip
is pretty,
select in there. That's the spy, probably.
yeah, it's some kind of like subset of spy that it speaks. It can speak one or two, no, 3 or 4 wire spy, and I'm used to thinking spy is always 4 wires, but like, yeah, we can read the documentation, and there's also
Cool.
other Arduino libraries out there that all of these e-ink display protocols are all pretty much standardized. So like whenever you're interfacing with an e-ink,
Yeah.
it's pretty much the same everywhere. The other stuff that you see here is this is all these capacitors make up a charge pump circuit. So to actually move the pixels, it actually requires higher voltage, but just like very low amperage. Um, and these capacitors basically provide that in conjunction with whatever this standard circuit is. Again, I lifted this from the e-ink display documentation. They just they say, you know, just use these components, put them here, and it'll work. So that's
And Paul, to explain to folks who don't understand the difference, between buses here between SPI and I squared C. I squared C is chainable, and so it's a bus that I can put multiple devices on and address them individually. SPI is something that I'm kind of dedicating to the display here, right? And so, if we're talking about breaking one of these buses out, and so we have a port on the back of this device, for example, if I want to plug in a temperature sensor that's I squared C, it makes sense for that to be I squared C rather than SPI or rather than UART or a different type of bus. Okay, I just wanted to throw that out there.
We
Yeah.
should think about also a single wire debugging. Or are we going to have that on here?
Yep, we have
Okay.
that.
Okay, cool,
Absolutely.
cool. Yeah, just throwing things out. And it's always nice to have an I2C breaking out somewhere,
Yeah, yeah,
and also a UART.
Yep.
yeah.
I'm just thinking from
And
whenever
so,
I
do
need
we
to.
have extra TXRX on the
Yep,
Pi that we can break out?
yep.
Cool.
We
Then
do.
I can,
Yeah.
if I have those, I can get into pretty much any device.
Yeah, 100%. And I think you know, when we add the ZAO connector,
Yeah.
that will probably bring out most or all of those things that you're just talking about anyways. Like I'm pretty sure the ZAO connector probably has dedicated
Cool.
ports for
Just had to check. Yep, yep.
yeah. So you asked about the
There we go.
single wire deep bus. Here it is. This is just a tag connect connector.
Yep. And this is actually, if we look at the schematic, you have this on the back of the PCB. Yeah, there we go. That J3.
J8.
Oh, J8. Yeah, gotcha.
Sorry, my 3D skills are not that great. Gotta turn this thing. Come on. So yeah,
And,
this is just one of those
what these
tag
are,
connects.
if anyone doesn't understand, those are things so you can have a connector that kind of locks to the board and uses pogos or like these little springy pins to
Yeah.
connect to the board. So
Oh yeah, perfect, perfect. Yes.
Exactly right. And they're also big enough too. Like if you just want to solder on, like if you don't have one of those connectors, you can also just solder on through these little pads. So yeah,
because
one
those
of
little
these,
connectors are kind of expensive, by the way.
yeah, they're $60 each.
Yeah,
But once you have one of them, you'll use it for everything.
I know, I know.
What else here? So I think we went through. Oh, the only thing we did not discuss yet is the secure element. So I kind of threw this in as a maybe we'll use this, maybe we won't, but it's super easy, as you can see. What is this? Is the same secure element that's used in Hotspot.
Yep, nice.
So this little chip can store cryptographic keys, and it can also do cryptographic operations like signing data.
Yeah.
and stuff like that. So
Can we explain the importance of this? Not just for the network, but I mean for the personal importance of this.
yeah, so like I said, I kind of just threw this in on a whim, and I think there's multiple different ways we could possibly use this. Um, I mean, one way we could use this is maybe this could turn into a IoT mapper device. Like I've thrown around this kind of idea, and I think other people have, of a secure mapper, which is you know something people carry around with them on their person and is mapping the Helium network as wherever you go. Now,
This is exactly what's used in the secure concentrator, by the way, everybody. Okay. That's what makes it secure. So if we add this chip, we make it a secure mapper as well. And then everybody's secure, I guess. Sorry to interrupt. I just had to throw that in.
yeah, I mean, I think we'll have to add a couple more things here to prevent gaming.
Yeah.
So, but this might be like a first stepping stone in the right direction, right? Like before we can, we have to start somewhere when we talk about introducing these new types of secure devices to the Helium network. So we have to have a stepping stone, and like someone's got to make a piece of hardware that could demonstrate the proof of concept. So this could be one such thing that could demonstrate that. But you need a secure element to be able to do those things in the first place, and it's super cheap. And well, how much does anyone know off the top of the head? How much do things cost?
I think it's cheaper than the power chip. Yeah.
There you go. It's cheaper than like, the $5 power chip. So that's potentially one way we could do it. Another way we could use this is when we're talking about secure messaging.
Yeah.
How do you know you're actually interfacing with someone who says that they
Right.
who they really are? How do you prove that? Well, you can prove that cryptographically using the functions that this chip provides.
There's Paul, there's another use that I think we talked about in the past. I think I was talking to you about it, was the ability to use an external USB dongle that then would relate to this chip and say, yes, this is licensed or this is secure with this dongle, kind of like a second key that way. It can relate to cryptographic payments.
Right.
Yes.
Yeah, I mean, you could technically, this could be a secure wallet, right?
Correct.
Yeah.
It's a hardware wallet waiting to happen with that chip.
The hardware wallet, exactly right. Yeah. So kind of like interesting uses there, and again, this is one of those things that could be populated or not populated based on if it's compelling enough to justify the whatever it is, $1, $2 per chip.
And so I guess, Paul, this is fantastic, and I'd like to go ahead and schedule, a weekly meeting for this community, kind of meet up on this project. I'd like to start talking about firmware, once we get the hardware solidified here, and get some boards, blown out on this, and see where we're at. But I know a lot of people are really wanting to jump on firmware, and I think we're at a point here where we can really, start pumping on that.
Great, that's awesome. Yeah, I think a weekly chat would be great.
Excellent.
Yeah, as far as the RP 2040 front, I'm already doing some preemptive work on that, so I'm focusing that avenue. If anyone wants to jump in, I'll make sure my repos are available and stuff. I'm also getting a chip from the similar outfit from Solder Party. Solder Party has a chip showing up. It's basically an RP 2040 with an RFM 95. It's a full board. Supposedly it works with it's not the Radiohead library, it's another library, and it works really well for Pico. Basically what I'm doing with that, I'm reverse engineering what they did. It's open source. I just want to see what libraries they're using to talk to the Pico through the SDK and get kind of a finalized set of hardware that way.
Cool.
So that's it's the front I'm going on for other avenues, and it just works in with this too. So I'm heading that direction.
Awesome. Hey guys, I gotta jump. I got another.
I do as well. Paul, thank you so much for giving us the walkthrough today.
Oh, yeah,
take
great.
care of yourself, and we'll catch up on Discord. Sounds good.
Bye bye.
Everyone, take care. Thanks for joining. Adios.